later after the classes.
And your email, please. We don't have it yet.
No problem. You'll get it. I'm live. All right. Thank you so much. You're all welcome to week 2 of deep learning. I know everybody can hear me here, and I hope those online can hear me. Please, can you hear me online? So please just confirm if they can hear me. So we'll just continue. 9:17. Good, they can all hear. Good. All right, so we're going to continue with deep learning, and we'll just proceed from where we stopped last week. So remember, we dealt with the description of the differences between machine learning and conventional programming. We talked at length about them. We saw the progression from input to rules, from rules, input, and how they were all operated. And most especially, we saw the difference in the approach from what we used to know and from what we know now. And then we talked at length about neural networks. I hope we all remember. And that is actually deep learning. When we say deep learning, we are actually looking at neural networks. In fact, there are some materials. I'm sure, have you people been studying materials?
Yeah. I didn't get this last week.
This, yes, you got it. No. It was on the slide.
No, we didn't get the slides.
You didn't get the slide?
No.
I'm not the culprit.
And it has not been uploaded.
And it has not been uploaded. I have it, it's there. I gave it out. So just be patient. The organizers will upload it for you, but I've already given the slide. This one is already with them. So I'm sorry about that. So maybe it's end of year things. Everybody's trying to round up for the end of the year. Sorry, that's not supposed to be an excuse. Okay, my apologies. And so how many of you have been reading materials based on what we discussed the last time? Some practicals, doing some practices, trying to research on what we discussed. Please do take time to do. You have to do it. It's part of your work. You have a question? Oh, good. Good. So please look into it. And there are so many materials out there. But please always try to censor them and see the ones that are tailored to your area of interest and specialization. Today, we are going to, you can see the highlights there, we're going to demonstrate an understanding of the advanced use of neural networks and understand, I keep saying understand, we are actually trying to build a foundation. That's why this is just introduction, because there's a follow-up to this course. And when you want to go deep into, the actual design of different artificial intelligence tools, that's what we hope you will progress with and be able to design these tools. And so this is what we're going to be dealing with. So we are going to, today, we are going to soak ourselves into different terminologies. We have to understand it, because when we progress, when we start, the end is to see the structures of different deep learning architectures. How did the structures come about? Why is this architecture like this? What is it supposed to be used for? Which one should I use to build which interface? Do you get it? And so that's where we are going to. So just to give you a sneak peek into our destination. So to be able to do that, we have to understand intelligent algorithms. We talked a little bit about intelligent algorithms last week. We just said intelligent algorithms, and by the time when you looked at the way that inputs were going in, the way you are using a comprehensive data set to train your models, we had an understanding of how our algorithms will be designed. Because this time around, it's not traditional, this is machine learning. And so you can see that the algorithms are becoming intelligent. So you structure it in such a way that it can think for itself and give you output by itself based on the data that you feed it. And so let us look at bias. These algorithms, they have their biases. So that's where we come in. Please pay close attention. We're going somewhere. They are the building blocks for our deep learning architectures. So the first bias there, we have data bias. In a nutshell, I said perpetuation of systemic or historic biases. What do we mean by all that grammar? Let me explain. Are we good? All right. So now when you see data, you feed the data to the system. Let us analyze the kind of data that you are feeding to the system. It is based on the data you collect, right? It is based on your experiences. Let us use that. Your experience with a particular process. Because of that, you extract that kind of data and then you feed it onto your system. I hope you know that this what we are talking about machine learning. We are not like taking in information as humans. No, you are feeding the machine with data. And so look at, I want you to critically analyze the kind of data. Let me give a real life example. It was a big thing. If you go online, just like I said, read more about data bias, and then you will come across this that I want to describe. In the US, from their records and from what's happening in the security sector, they started feeding the AI with the description of criminals that are apprehended and, sanctioned or imprisoned. And so they were feeding the AI with those kind of data about the kind of criminals. And so there was a scenario online, can you hear me? There was a scenario where an AI was asked to point out the possible criminal in a crime situation. And the AI quickly just pointed a black man.
That's bad.
I mean, I don't know if we have white people watching, listening online, but imagine that. I'm trying to explain data biases. The AI was fed. That's why you are all here, and I'm so excited to see you people are here, because I think, and I not think, I know, and I strongly believe that we should learn more about artificial intelligence, build systems that are local to our environment. You don't know how that data was fed, and you cannot fault the AI, because when the AI I mean, come on. Probably the when they log in the criminals that have been caught, the majority probably will last. So when it sounds somehow and it's like, how can you just do that? It could have been a white person, that committed the crime. But the AI went straight for the black because of the kind of data. So you can see that kind of bias happening. You and me, you see the way we reacted. But we are not machines. We are not AI. We are humans. And we know in some areas in the US, probably you won't doubt it is a black man, but it could be a white person. And so you can see, I'm just trying to say it's a perception of systemic or historic biases that is happening. So when you are trying to use this tool or build this tool or design this tool, this particular data, you have to take it into consideration, by the way. What kind of data? And then the next one, we have design biases. Yeah. So what do we understand by our design biases? And then it says innate prejudices in the coding of the algorithm. Now, how many of us code here? How many of us write codes here? You write codes. Typical of most of our computer brain. All right, but how many of us understand coding? You understand basic program, right?
Yes.
That helps you to do some things. You understand algorithm. And then you have your style. You have your style. You believe there's a certain way that it should be done. There was something a relative told me, like he was working on something and he said he believes that for every change, there should be a comment in the code. Good practice, right?
Yes.
But that's his own take on it. And he does it. It's a good programming practice. But another school of thought will say it depends on the audience that will ingest these codes. And so, good morning, you're welcome. And so I do not have to put the comments. They clog the system, and I don't want, some of them will at the back of their mind be saying that it lengthens the LOC, the line of codes. It lengthens it. So you see, those things will come into play. Unfortunately, we do not have a structure and we do not have a standard. Congratulations. The VC and the CCAI, we are trying to come with what we call an orchestration approach to artificial intelligence. And so in that how many of you know the waterfall model? These are different models. They are standard models. And so many other models. So there's no one. Check, read more. There's that structure of how to build, an AI is not there. They are different. Anyway, we are all on the same level at this stage in AI worldwide. So let's try. Okay? And so you see design biases. You have what you want to do. B has what he wants to do. C love what she wants to do. And so why? All those biases will come into play. Do we understand?
Yes.
So let's put that aside and proceed. We are going somewhere. And so, I did. All right. So we're looking at parameters. We know about the biases. We want to learn about the weights and the biases, making what we call our parameters. And then here I wrote the adjustable values to try to reduce the value of our loss function when training. How many of us were not in the last class? We were all there. Okay, both of you were not there. Okay. And so we talked about the loss function. Don't worry, we're going to say more about the loss function. We just mentioned it in passing. And so here it says a mathematical process that quantifies the error margin between a model's prediction and the actual target value. Grammar. Let me explain. Now, you have an AI, you use AI, right? Okay. Now, with that AI, there's something you're looking for. You know it. You probably don't know everything about it. That's why you're searching. Anyway, but there's something you expect. Okay? You, as the person using the AI, you have an expectation. Now, the AI, what does it have? A prediction. It can predict accurately. And so you look at the result and you're like, yes. Or sometimes you look at the result and say, and then you go back to your prompt. Did I give it the right thing? Is it really getting the question? So you tweak the question, right? And then you put things into place so that its prediction will be at the same level as your expectation. When that happens, the loss function have tended into 0. There is no error margin, no error again, and you're good. That's what we call the loss function. Please, when we start talking about the architectures and we start doing some practical applications, I will just be saying loss function, designed by us. I will not explain, but I believe we all understand.
Yes.
Okay, so you understand what the loss function is. Paraventure. What you expect, compare it with what is giving you. It's so different. The loss, the error margin, the error is high. That's layman explanation, right? And then it's hard. So when you look at the mathematical function, you are getting some kind of values that is not adding up. And it's not helping your calculation tend to 0. So the closer it is to 0, show how accurate your system is working. And that's what we mean by the loss function. These are definitions, by the way, like I told you, for those of you that are just coming, we are going to be seeing concepts. We're going to be understanding these concepts. We're going to be using them. All right. So what are the roles of the loss function? Somebody will say, okay, fine, it's loss function, so forth. So good, loss function. Error margin. Without this loss function, it's so key in AI. You cannot measure your performance. We've just explained this. And then you have no direction, so to say. Are you seeing that when you are looking at an AI system, what's the first thing? You know, the first thing for an AI design person, or somebody that's going to use an AI system, is going to work with it, to change it, or do anything. Many people look at it from the point of view of just use. They just use it. This AI is not rubbish. Let's go to another AI and then try it. But for you, that is trying to learn more about AI, the first thing that goes into your mind is the loss function. The loss function tells you, it shows you the direction to take. How do I improve the system? How do I change it? And that's why we are saying that the direction for improvement. And then it balances bias and variance. Effective loss function helps to balance the modal bias. I hope, from your last introduction to AI, you understand what we call by oversimplification and overfitting. Do we understand these two terms? Am I online? Are they still listening? Please.
Yeah. Yes, okay.
Yeah.
It's online.
It's all right. Cool, right? Excuse me.
Yeah, it has my thoughts, but can you put it in word?
What's the word?
When the model does well in training data, but badly in data capacity. That's what I'm saying. Yeah. So I don't know the psychopaths.
No, this day.
This day,
I know, my parents begin, right?
yes.
It's just the.
Yes.
I didn't, did he ask for that?
Yes. Now this part I said, what are you working on? What would you like to work on? Something about that.
I think I put AI in the
You know, like she said now, the whole thing now is multidisciplinary.
like you know, healthcare.
Like there's urban plan, urban psychology, urban law, transportation, urban this, urban that. That's a mind.
You're supposed to have an idea, like if you're going to a PhD, you can go and solve a particular. So you're supposed to have one in mind.
Yeah, but there are a lot of interesting parts to it. Okay, a particular one I love, that I know is this part that comes with planning with people, something like that. Like the community engagement aspect of it, kind people along where you want to bring about development to environment. Yeah. That's the aspect.
Yeah, I can actually help you with the course, like, in taking it at that time, going there, it will help you lot there. What's now like the term for it? So like the
I'll be exemplary. What I know they make use of it there as a planner is not allowing the people not to plan for them. Yeah, actually, I thought I would be using this. That was
Well,
my
like I
thought.
like how she's like making mention of like let it fit your what you are doing.
Yeah. She even encouraged me because initially, taking my mental health, I'm not to help it just goes to one side. But what she says now, she's not bringing up my interest.
I'm sorry about that.
Research on it.
We are trying to come up with a structure for you because we're told that you will need to get some kind of CPN accreditation or something. You heard about that, right?
Yes, ma'am.
Okay, fine. So, where was I? So, talking about balancing.
Yeah,
Okay, yes, oversimplification.
So my understanding of over 15 is when the model you train perform well on the training data, but not so well on any data that it is. That's what I understand about 15. That's correct.
Where did you get that understanding from? I'm sure it's coming from some
Yeah. Yes.
varied, research and things like that. Overfitting is kind of the simplest thing. And when you say it's not understanding the new data that is being fed with, that's, he understands it's performing well, and then you put in more data, I would say yes, and I would say no.
Okay.
I'll explain. Okay, and then over simplification, they are actually words, grammar, everyone. But they are quite simple. Oversimplification, you gave it snack instead of you to give it swallow. I'm sorry, those online, I hope you understand what I'm saying. You are giving the data insufficient data to work with. And then overfitting, you are loading it with too much data for the task. And when you have Zena, right? How did I know?
How did you go?
I heard you say. I didn't say it. So you go, okay, what is your best color shade? Yellow. And then you just go and you see these gowns. They have 20 shades. You know they're up to that. In computing, you can see different shades, 20 shades. And they are all beautiful. Choose. Your mind is like, you have enough community color, right? And you just talk your. It's no longer wardrobe, it's wardroom. It's exactly what they call it now, no longer wardrobe. There's just a room. and then you put all of them different shades, you understand? And then when it comes to going for a particular application, and then you just get completely confused because you do not know which one to choose.
That's overfitting.
Overfitting. The data, you said, okay, fine, it needs data, and then you put too much for it to be able to swallow. There's what we call sufficient. You know, if there's going to be if there are going to be outliers, sorry, it should not be to the point where it will lead to choking of the system. Do you get it? And then oversimplification, you just like putting it something that's not sufficient. That's what we do in a nutshell. We'll go in depth into it. I hope you know that this is introduction. So let us not go to the point where we don't understand this concept. Balancing bias and variance, effective loss function, health balance, model bias, and variance, essential for models generalization to new data. And finally, influencing the model behavior, the loss function. This is the big one, the loss function. Certain loss functions can affect the model's behavior, such as being more robust against data outliers, just like I said. And then prioritization now comes into play. So what I'm trying to tell you is that when you are working with AI, you're working on an interface. I hope you know that there is what you now call, when we say interface, what kind of interface were we used to all this while? Those of us that are not computer inclined, when you have a computer system and you have programs, how do you make the programs interact with the user? By an interface. We design an interface, and then they understand. You can go to
the codes.
No, you don't need to go to the codes.
Like the front end.
Thank you.
Then I mean you as a programmer.
No, not you as a programmer. That's the interface, and then you are like you can talk, interact with the system. It's a big word. It's called application programming interface. That's what we have always known, right? It's application programming interface. But what we are seeing now, using this technology, we have what we call AI API. Wow. We have stepped up. Just like we stepped up from traditional programming and we entered machine learning. That's how we have left the general programming interface into AI API. There is AI API. Please read about it. This I call from DataCamp. Check datacamp.com. Read about them. They are good. They are quite good. You get a lot of materials from them. So that's what we have now. And so if you are using that sort of interface, you are most likely going to be, if not most likely, you will be particular about the loss function. That's the new way. Don't get me wrong. The old way is not gone. But we still do our basic programming. We still interact with our systems, right? You still use Google, right? Don't you still use, which one do you like using? You have dished all of them, you're not using AI. What do you like using, apart from Google?
Sometimes I use Microsoft
Edge.
Yes.
You use Chrome. They are still there. And so they still have their powerful interfaces. But yeah, they are varied. But then, even then, if you check Google AI API, you'll just be wowed. Because if you cannot continue to be in this industry, You cannot continue to be relevant if you do not flow with the times, if you are not with the current trend. And so Google would have been phased out. You see how powerful Meta is? Meta AI. So powerful. And so they check their interface. That is their AI interface. Check it. That's why I said go further and read. I think this brief holiday, I'll load you people with some research work. So you can go and read about these things and know more about them. So do we now see how important our loss function is? And the term loss function is no longer strange to us. So let us proceed. Do we have any questions? Okay. Okay.
It's the last. It's something about overfitting. Said loading the model with so much data. So my question is there a way to determine like a code or something to determine the
Which
right amount
the
of
right?
data?
Yes, there is. There's a way to do that, and that's a whole new area on its own. And there's a lot of research in that area. You will know, and especially when you start. Another clear indicator is your output. And but your output is giving you outliers. You begin to wonder, oh my God, wait, calm down. Maybe I should, go back and restructure it. They are working on that. There are different programs to help you mitigate that issue. And you as a designer, you have to know, somehow with experience, you'll get to know when enough is enough.
Okay, so I was thinking overfitting loss function. Okay, so is it not possible for me to know if it has overfitting based on the result of the loss function?
Yes, there's a direct, not will I say direct, there's a relationship between it. Yeah, there's a relationship between it. You will not drag me into extra. This is introduction. We are going to keep ourselves to introduction. Then when we get there, I will bring it back. And then we'll begin to talk about that, okay? Remember, we are all going to be on the same page, even if you have a computing background. But do we understand? Yes. So, and for everybody. All right. This one, we didn't talk about it last week. We didn't really talk about it last week. That is why I brought it here. It's not something, you cannot even overlook this when you are talking of outputs from an AI. And so there we said is the integral. You see it? It's essential, actually, building blocks that enable neural networks to learn complex patterns in data. Let me go back. Last week, we had a diagram that looks like in the afternoon class, the later morning class.
B class.
The B class. They said it looks like a beehive. It's a kind of, it looks like a mesh diagram, where you have the input and then you have different hidden layers and you have the output. The function, we talked about different layers of functions. The function, the programming function that helps all those hidden layers to come together to a coherent output that is single is what we call our activation function. Every AI have an activation function. So if you cast your mind back to that diagram, you're going to be seeing another structure shortly. You will notice that the activation function is the one that makes most of the input not to be linear. What do we mean by linear? They help you to go deeper. If it's linear, okay, I just put A I put B, I expect C. If that, gives you some kind of understanding. But by the time you are getting A mixes with different categories of B, and you're actually getting C. But so many things happen there. Just like I told you, how was it able to analyze the different functions to come out with an output that makes sense? It makes it not to be just simplistic. I'm not giving you exactly what you want. Now some context. Right. Let me come back to let me explain. How many of you were here when we talked about the candle? I still go back to my candle analogy, where the little child just sees the candle. You see a beautiful candle, right? You like it. And so, if you like something, what do? You get it. You play with it. Are you wrong? You like it. And that is a child. But the mother or the dad knows that if you touch this candle, this is what will happen. What made the parent know? Experiences. Probably they have touched it. They know what will happen to it. Does this child know? No. The child is not wrong. And so when you're talking about the child's output, beautiful candle, look at the light, I touch it, play with it, nice, simple, it's linear, straightforward. But by the time all those analysis start to come into play, touch it, you will get bored, the wax will fall on you, you will go to hospital, and the output is what? Do not play with it. What helps you to bring that cohesion in all those hidden knowledge, what we call hidden layers, is what?
Activation function.
That's the activation function. That function must be in place. Most AI designers put that function there. You have to understand that function. And as you progress and you are designing something like that, you have to be able to design a function that is that good. All right, so let's quickly run through is the integral building block to enable neural networks to learn complex patterns in data. They transform the input signal of a node in a neural network into an output signal that is then passed. The input signal, that's what I've just explained. So this is just like a summary. Into an output signal that is then passed on to the next layer, thereby ensuring that neural networks are not restricted to modeling only linear relationships between inputs and outputs. And finally, it allows these networks to learn highly complex mappings between input and output. We have talked about two functions now. We talked about the loss function, and then we are talking about the activation function. These are things we should put at the back of our minds when learning about AI. All right, so there we go. Behold. Even if you are not a mathematician, from all this background, do we understand this? All right. You see all this grammar I talked about feeding your AI with data. The inputs, all these inputs. We just put 3 nodes here. It looks as if it's 3. Then we are saying from 1 to n. N can be any number. Can be 2,000, can be 2 million. We are looking at from 1 to n. So this is just telling you that when this data is fed into the system, we have weights. Weights are talking about our data sets like we discussed earlier. It could be anything. it forms part of our parameter. I hope you know that our parameters are what? A combination of what?
Weights.
Our weights and our biases.
Okay.
Weights are just the normal input that you put into the system, depending on, we talked about what the weight is. It could just be anything that you want to check, that you want to find out, that you want to research on. These are the weights. And then
this E and is different.
this is not E, this is summation. It's a summation symbol. Yeah. This is a summation symbol. This summation is the total sum of the combination of your biases and your weights. And it could have just moved from this major node. Let's cast our minds back to our biological neural network, the biological one that we talked about. Did we see the way I made you go to become medical people, right?
Yes.
And then you saw the way all the nodes were working together to have just one output. All right, they were all working together to have just one output. This is the artificial one. Artificial intelligence. This is the artificial one. It's not the biological one. It's not as complex as the biological one, but it is doing the same thing basically, using that concept. So I wanted you to understand that one, to understand this one. And so this summation sums everything together, putting the bias, putting the weight, the different kinds of input, and behold, your activation function. It has to pass through your activation function before it gives you an output. I hope I've not confused you. Straightforward, right?
Yes.
Okay, good. All right.
In any way, does the activation function help with sealing out the biases?
Exactly. Let's go back a bit. People should be asking questions.
So that is very important.
It's very important. It helps you sieve, not just sieve, okay, let's sieve the biases.
Okay, is that what you said last week, that if we have the data, find out if the student is going to come late or not, then we decide to unknowingly add the name of the teacher. If it's deep learning, at the end of the day, we are likely not to have the name of the teacher in the results.
It receive it.
Okay, so that's activation function.
It helps to do that.
Okay.
The activation function is in the deep learning algorithm. It's an intelligent algorithm that will help you to sieve. So it is not only to sieve out bias, it also helps you to fine-tune the weights, the kind of weight that is entering into the system. And so at the end of the day, you have an output that is most likely to have a zero loss function. You see why I say you should understand the terms. So when I say an output that is most likely to have a zero loss function, what does that mean? Simple, in a nutshell. Let us use grammar now. There is zero error. Thank you. All right.
Someone online said, can you please use a pointer as you explain?
Pointer. Oh, really? Yes. I don't have a pointer. I'm sorry. Do you want me to go back and talk about it again? If you want me to talk about it again, I'll just run through it again. I don't have a pointer just now, sorry. Maybe in the online class, I'll be better prepared. We are looking at the inputs. We talked about inputs ranging from 1 to any number that you put there. That's why n stands for, any value that you want to put. And then we have our different weights, and then sum them all together. It's a combination of all our weights and our biases, making our parameters that we need, goes through the activation function, and then we have our output. And our output is targeted at having what? A zero loss function. Victoria, am I okay? Am I pardoned?
Someone said, my question is, how can I have the basic knowledge on this programming stuff? Because like myself, I'm not a computer scientist, but rather a biochemist. I need more recommended materials for people. Thanks.
All right. No, that's good. It's a good start that you want to learn more about this. Like I was very careful last week in trying to break everything down because of the audience, and we were able to flow. Meanwhile, try to understand what we are trying to say, but subsequently, it will do you some good to read up. Like I just said, there are some, like Datacam, that's one of them, datacam.com, and then you go online, use YouTube, learn about basic programming, please read in depth about algorithms. Read about algorithms, the structure of algorithms, what they are, how they are created, how they are used. It will help you. So you have to have, if you want to have that kind of background knowledge, you go and read it up. Okay? I don't think we have a course on ideas that talks about, but I think basic programming, I'm not too sure. I kind of like, I'm focused on the AI thing. That I think there's software engineering, right? They are doing software engineering. So do well to try to, learn something from there. But what will help you the most? Go online, go to YouTube, and then you see they'll just discuss the basic concepts. And from that, you will know. Look for the ones that are pictorial. Yes, they can help you see how it works. Don't feel that you're not going to flow with all these things that they are saying. No, that's not right. Oh my goodness, I put you to sleep. You see, I really try not to go too technical so that I don't put a lot of you to sleep. I'm sorry about that. Sorry, you've been quite active though. All right, so can we proceed?
Yes.
Okay, so deep learning processes. Let's look at our deep learning processes. We are moving fast in this class. You are not, you are understanding too much, so we'll close early. Are we okay? All right, so I know it's the holidays, so online, we are still as active online like on site. Please watch out for your platform. There are going to be some assignments. I like research, so I'm going to tell you to research on things and why. Okay, I'll tweak it. So we'll do a lot of research because I want people to read, just like you heard what your co-student is talking about. They want background of how so many things work. So I'm going to tailor most of the assignments to you getting a kind of background knowledge. If not, what is the point of everything that we've been doing? Okay, deep learning processes. And so we are looking at, will I say, is that 1, 2, 3, 4, 5, 6? I'll say 5 basically, because the last one is going through the 5 all over again. In fact, 4. Going through the 4 again. Because the one, I said, the processes are repeated for multiple iterations, with the network becoming increasingly accurate as it learns from data. We know we talked about data. You asked the question about data the other time. How does it get better about knowing me every time I go to eat? That's the machine, the AI, because it's learning from the data, it stores it and learns more, because that's what the algorithm told it to do. It stores it and learns more, it stores it and learns more, and it updates. And so it's getting more and more knowledgeable and powerful. And so the data preparation, the process, the deep learning process. So from everything we have been talking about, this is the process. The first one is your data preparation. I do not have to go back and be explaining what we mean by data preparation, data bias, design bias, and so forth and so forth. We know. So the network is fed with a large data set. Please, a large data set, not too large. If not, we'll experience what we call good. All right. Each example consists of input data, images, text, mostly text, okay, and corresponding output labels, classes, and different predictions. All right. So the next step, am I moving too fast? All right. The next step, we'll talk about forward propagation. Please take note of these terms. Take note of these terms. The input data flows through the network layer by layer, like we saw in the last diagram and the former one, with each layer applying a set of learnable weights and biases. Do you get it? Which we have seen before. And then the errors signal measures the differences between the network's prediction and the desired output. Okay, there's some certain measurement going on there. What is one of the things? Okay, let me ask this question after the next point. Backward propagation. The error signal is propagated backwards towards the network, layer by layer, to calculate the gradient of the loss function with respect to each model's parameter. And the second one says the gradients represent the direction and magnitude of the changes needed to reduce the error. Please, class, the error calculation, the backward propagation, what's going on there? Something, there's a function going on there that's making this happen. What's that function?
The loss function or activation function.
You see what the activation function is doing. So when you look at the process of deep learning, it gets to that stage and then the activation function kicks in. And this is taking place. And then it comes out. And the output gives you the update, the most relevant and the most current update. And then it says the model's parameter weights and the biases are updated based on the gradient. All right. And the learning rate. The learning rate controls how quickly the model adapts to the new information. And just like I said before, this is the basic process. And for the iteration, you have to go over these steps again. In fact, actually, you go over the forward propagation, error calculation, backward propagation, and then you update again and again. This you've already done from the beginning. Sorry, did I? You're like, are you good? Okay, because you've already fed data in, and then it does all this, goes through all these processes, and then the iteration. You know what an iteration is? It goes over it again, it goes over it again, depending on your AI prediction to show you where to stop. So when it tends to 0 or 0, you got what you want. Good. And so you tweak more and more. Well, do we have questions?
Data preparation.
Yeah.
It says each example consists of input data,
Yeah.
e.g., images, text.
Okay.
And that's that part. I'm not getting it. What is?
You know, like I told you about weights, your input data, what do you feed into the system? so you can begin to do is iteration. What do you feed in? Your data. Your data could be, just like I told you, it could be text. I said mainly text. You know, most times we just do text. But you could feed photos. You could feed videos. When we say images, we're talking about photos. Calculating the pixels. We'll be calculating that maybe later, or maybe when you go further in the course, you'll be calculating those inputs. That's what we mean there. This example is generic, but there are several other inputs that can be fed. Are we good?
Yes.
All right. All right. Now, our second to last slide, right? Good. Good time. I want to leave here by 10:30. Is that okay for everybody? Good. We can have a discussion. We talk about what we are supposed to do.
Taking the second.
Yes. The same for the second B. You call them B, class B, when they come. So, all right. What kind of mechanisms come into play when we having deep learning processes? These processes that we're talking about now are the processes just like that. We need as much as possible to know what kind of mechanisms come into play. We call them mechanisms, but what kind of another school of thought might say the approaches you use, the techniques. We have four major ones there. The first one is your feature extraction. Neural networks learn to extract relevant features from the input data, which are then used to make predictions. That extraction process is very key in a neural network. Just like your biological network, it needs to extract some, like for example, when the output is pain, for example, what kind of thing did it extract? I know you're a medical person. When something hits it, how does it extract it in medical terms?
You mean when someone hits?
Maybe somebody hits something. That's signals, right?
Yeah.
That is input hitting the body. What? Just give us a brief. Maybe you can explain this extraction process we're talking about.
Well, there's like a series of activities that go on in that like seconds.
Thank you.
Like maybe once you're hitting, the neurons that were involved in that at that particular position, maybe your finger, then it will go to different parts of your body before getting to the brain. But the brain, it will have to like understand what just went on. So there might be a lot of things that went on, but there's a particular thing that you feel that it interprets it, and that's like pain, and the cause of the pain. I don't know if
Is your point?
It makes sense.
Yes. Do you know that is exactly what we're trying to say? Are you really listening? All right. But that's it. That's what we're trying. She has just explained it using the biological neural network. And so we are looking at the artificial neural network. And then I like when you said there are different is it activities? Yes. The different activities that are going on within that second. Now, when we say feature extraction, it extract what? Why didn't it come out as? I said pain. The output is what? Pain. Why did it come out as? Why is the output not happiness? For example,
and there are actually people that when they feel pain, they become happy, but maybe that's like abnormality.
thank you.
Yeah.
If the system is not working well,
Yeah.
but because naturally it's predicting what pain, and then you begin to see happiness. You're not conscious. Something is going seriously wrong there. The person is, like psychopaths, right? They are not well. Unfortunately, we do not prioritize mental health in Nigeria. It's a big issue, especially now with our very wonderful economy. Mental health is a big issue. Please try to take care of yourself. I do my mental health. Just a digression, Sha. Try to think about, why am I doing what I'm doing? Am I doing it right? Is this feature, like this experience, am I extracting the right thing? For example, you just behave in a certain way. Sometimes talk to yourself like, what did I do? I do it really when my children were growing. I had to go and read about it. Talking about feature extraction, I had to read about how, I think I learned it somewhere early. I'm just grateful for that. How to deal with young children, how to deal with teenagers. Now I'm reading about how to deal with that. So I don't want to talk. You know, there's when you talk to a child, even if it's your child. So when we are using this kind of mechanism, the neural network is learning to extract. We are particular about the words that we are using. We said relevant features, not every feature. There are some feature when you hit that, so many features come into play there. But the expected one is, because sometimes your brain has already kicked in that. The network already knows and expects what? Pain. If I somebody that's even watching you say, they know that pain. And so the brain, correct brain, will use the relevant features and bring the output. That is what pain. That's just the example. That's trying to explain the first point there. And then next, hierarchical representation. Now, deep neural networks learn to represent data in a hierarchical manner. With early layers learning low-level features and later layers learning high-level features. Before now, we talked about interfaces. Most times, this technology is built on sequential APIs. When they say sequential APIs, they are actually looking at different layers in a hierarchical manner, one learning from the other. Not just, there's functional, but that's a whole new concept to learn about. But when we talk of hierarchy, one layer is learning from the other layer, build from it and go to the next layer, build from it, and, just like that. That's what we mean. It uses this kind of mechanism to come up with those processes that we saw earlier. These processes. Hi, hello. You saw, okay. All right, I hope it goes to the next one though. Next, distributed representations. You can see it right there. Neural networks learn to represent data in a distributed manner with multiple neurons contributing to the representation of a single feature concept. I'm not going to explain that. We all know what that is, right? Do we have any questions about that? I will explain if we have. Ma? Okay. Yeah. The distribution and all that, fine. It's not a hype though, but it's just like, it looks like one, right?
Yes.
Okay, abstraction. This is a big one. It's a major mechanism that deep learning uses. Neural networks learn to abstract away from irrelevant details in the data, focusing on the most important features and the patterns. Now, that is where, that is where the system presents itself as very intelligent. The ability to abstract, the ability to separate different entities the ability to choose only the relevant ones for what it is intended for. That abstraction. It is not deep learning if it does not have this particular mechanism to be able to abstract. So it's no longer simplistic. We are looking at this particular mechanism for every deep learning process.
So not every machine learning is deep.
No, machine learning is the start. And so from machine learning, we go into deep learning. You remember the progression from last week? So machine learning can be very basic, like supervised learning. This one is machine learning. The supervised learning is just straightforward. Almost reminding you of traditional programming. You understand? So, but we have progressed from there. Systems are becoming more and more intelligent. And for them to become, we started this whole class today with intelligent algorithms. Intelligent enough to know that, yes, just like you are intelligent enough to know that you should learn about AI for your different fields. Some people will tell you that AI. Then forget them, they have brought another thing again. Really? They are not, well, intelligent in that area. They are intelligent in other areas. But we are talking about abstractions now, right? Okay? All right. So we'll get there. We'll all get there at some point. We'll get to know this. Even if you are not taking classes like this, know about it. Know about it. Know what is going on. Use it. And it's not just enough to use it. Know the dynamics of his working. In case, just in case. All right. My slide is not going. It's going to the last one. It doesn't want me to leave. Hey, sir. Last slide. No, it's showing here, but it's not moving. Okay. I know why it's freezing. All right, thank you. So you have to force it. Okay, thank you for that. Finally, I don't know why I'm happy because it's holiday. People are going on holidays. But so far, you okay?
Yes.
Okay. So when we come, online, when we meet online, we are going to be seeing the different deep learning architectures, like I told you. And we needed to have these building blocks to understand why the different architectures are the way they are and why they are used for specific AI processes. Do you understand? And what's the end of it all? When you are face to face with an AI, or you are designing one, trying to use one, you should know the kind of architecture you should use for which one, depending on the kind of output that you targeted. All right. So, patterns learned in deep learning. Linear patterns. Neural networks can learn linear relationship between input features and output features. When we talk of linearity, linear features, do we really apply the activation function here? I want us to debate. Do we remember our activation function? Do I have a question, please? Check online if there's any question.
Someone said they have a question.
Yes, please.
One back.
All right. When we talk of, look at this first one, linear patterns. Neural networks can learn linear relationships between input and output.
To still use it because since it's deep learning,
Do you believe that will you still need the activation function? Why? She said because it's deep learning, so it will just report it like that.
Activation function, the way you explain this to, it's like going through a steps. So if you are doing any other patterns, so activation to need to go through a step.
Okay, you believe
to recognize.
recognize the pattern. So the activation function is still there. All right. Do we still need the activation function? Because they are saying something now. Oh, but we are talking about linearity. And we said activation function can help us to, analyze processes in such a way that we don't just report linear outputs. But for this first pattern, do we still need our activation function? Yes?
The first one, right?
That's for these linear patterns. We're talking about patterns that we learned. We are learning different patterns. Why? It will form, when you see a linear pattern, it's giving a structure. And when we talk about structure, we're talking about architecture, right? Remember, we are going to different deep learning architectures. So my question here is, do we still need the activation function? Those of you that say we still need the activation function. 1, 2, 3, 4, 5. Do we still need the activation? No. Steve, do we still need the activation function? Yes. Answer. Do we still need the activation function? Felicia. Oh my God, it is your season. Felice.
Felice.
No, you don't have it, right?
My season, yes.
Okay. Do we still need the activation function? We still need it. You are right. We still need our activation function, please. All right. So the next one, non-linear patterns, neural networks and learning was blah blah blah. We have the special. Please pronounce that. The third one.
Something special.
Okay. All right. Okay. Thank you. I didn't study English. Special patterns. Neural networks and learn special patterns in data such as images and videos. That's when those kind of patterns come. But so that's where, I talked about pixels. Please read about it. And then you see a kind of distributed pattern. Do we understand that? Don't worry. I don't want to put more people to see. And then we have the temporal pattern in data such as speech and time series data. From here, the different patterns in deep learning, we just categorize them. We are looking at almost every kind of data, no matter the kind of data. But we are just trying to separate them into the category they belong, because eventually we want to see our deep learning architecture and how it was built. Do we understand? So that's where we will now be going to eventually. So that's it. This is the time you ask me questions. Questions from online?
And architecture, you have many patterns.
Yes, we can have many patterns. It's as varied as buildings. We are trying to simulate real life. It's as varied as different patterns of buildings, different patterns of designs. But this time is digital. And so we can just get lost in it. We'll have different patterns coming up. What suits you best? What will give the best output? That is why I said for this break, I know it's the time of relaxation and all that, but learning continues. Try and go online, look at the different patterns, look at the architecture before we come for the next class. Look at the different architecture. Read about it so that we can just have a discussion class. We'll talk about it, you look at what you have learned, and then ask me questions about how they work. And then we'll be on the same page. And from there, we'll now begin to see the different applications and the different application areas of these different deep learning architectures. Are we good? All right. Question online.
Please, I need a kind of progression of this learning. So I think, for example, now for someone in this class, you have to know first about data and data preparation. The type of data we have and preparing that. Then from that, we move to machine learning. Then from that, we now move to deep learning. How to confirm that.
No, you have been doing well so far. We are progressing right because the last was introduction to AI.
I mean, as an individual now, too.
Okay, as an individual,
Yeah,
no, you are doing good. This the whole process, that's how it's supposed to be. In fact, just like we discussed just now, we're trying to come up with a structure, a proper structure. And then if you follow that structure, you know that you are on the right path. So, but so far, we're not doing badly. We first of all do the introduction to AI, that's the general stuff, and then we're going into deep learning, and then from there we're going to the next module, and the next module, and the next module. And so we'll go and sit back and look at the next module. Does it capture what is required for you to pass your exam? And all that. All right.
Thank you.
No problem at all. Thank you.
Someone said, are there going to be practicals on this topic for better comprehension? Please, I earnestly would answer.
Okay, practicals. I mean, like, that's
Building a model.
And architecture.
an actual architecture. We are going to have some sort of, from the materials that are being prepared, we are going to have some sort of practical, but building an actual model with, hardware and stuff. And we are not going to. Okay, building the software.
Person is not being specific, so maybe person just said, are there going to be practicals on this topic for better comprehension?
Comprehension, of course. We are going to have some sort of practical, but that the physical building of the system, you probably might need to come and see. What's your name? Sadiq, sorry. Sadiq, in the maker space. And maybe you come physically. I don't know where you're learning from. We have a lab where we can try out some of these. We'll try our best to see some practicals. I will try to bring up some practicals as best as I can do virtually, and but it is going to be best if we can get our hands dirty in the lab here. I don't know if that answers this question. I know that there are going to be, there's something about introduction. It kind of whets your appetite for more. This is just introduction. There's so much more. There's so much more. Hopefully, you will be interested enough to pursue a career in this part, and it will be very rewarding. Any other question? Any other questions from online? Yes.
He said, go ahead. Said, Mark, can you explain why the activation function is applied in linear patterns?
Okay. Everybody, at least most of us here, agreed that the activation function should be applied. So let's just go to this. All right. I don't know if you can see this. You can see that before an output is displayed, or before we achieve our result, which is our output, we have to go through these processes. And just like we said, if you look at the forward propagation, error calculation, backward propagation, something is doing it. It is our activation function. This process will not be complete if the activation function is not performing these different activities. These three major activities. Do you get it? That is why even if your output is linear, it will still have to process it and give you a linear output. If it's more complex, it will do that, but it will still have to do that. It has to be there. And it will still help you not to make all of them linear, because if you don't have the activation function there. Almost all your input result in what? A linear output. That is it. If we go by the traditional way, it will just result in that there will not be the separation of the different entities to bring about, just like we talked about the biological what? Neural network. So the activation function has to be there when you are talking about the deep learning algorithms. I don't know if I've answered the question. Is that okay? Any more questions?
Is it possible when designing a program to use more than one API?
Yes. You can use more than one. You can use more than one. You just know how to use them. And that is why you have the AI API. With the AI APIs, you can do that. Yes. You can exploit, right? It's quite interesting. It's not as complex as it looks. Any more questions? So can I see you online subsequently? Yes, I was told that the next 2 classes, since it's a holiday, Boxing Day is on the 26th. So I'll see you online. And then we'll interact online. In the end, I'll prepare your questions and then ask put all the assessments and I'll put online. Okay. All right, thank you.
So we're meeting next week online.
Yes, it continues. There's no break.
Then we'll resume back.
No. January, the 2nd, right? The 2nd is most likely a public holiday. The next Thursday is 2nd. So
What's the next topic?
that's a new Moodle. Yeah.
So you'll get to see me.
I don't know who will be taking the next Moodle, but it continues till the last Moodle. Thank you so much.
Make sure you write your ID before leaving. Everybody? Huh? Okay. What was your name directly? Okay. No problem, you can continue. Okay. Have you taken your ownership? Okay.
Did you respond to me?
No. Okay, you will keep it.
Okay. Or you can keep it.
By 11, we are starting the next class.
Yeah, class, right.
Okay.